Hello, students. This is a video on how to use WDS 1.30, which is one of the first search engines that Dave Rowe wrote. And this is, it's called, on our computer, it's called Rowe's WDS 1.30. You'll see it as an icon on your desktop, but I'm going to start it from here on mine. So I'm going to double click it. And there it is. And this is, it opens a folder, and the folder has the database in it and other things. Please don't bother with those because you may actually harm them. Only click on the application. And the application come up, and you'll see it's reading that database right now, right here. It's reading and reading, and it's ready. You can't really use it until it finishes that and it's ready. Now we're going to do a simple example here. I'm going to say that I want the RA to be anywhere from, let's say, 20 to 22. And this is the selection. This is a database of about 140,000 WDS stars only, pairs only. And we'll start maybe at 10. This will be 10 north. Well, actually, let's do something. Maybe we're going to be looking at a normal. We're thinking about a normal double star. So with LCO, we can look south as well. So why don't we just go from, let's say, minus, which would be south, minus 60, and let's say this is plus 50. That's good. That'll give us a wide range around the center of the celestial sphere. I'm going to do minimum magnitude here of 7. I don't need to go something really bright. I'm going to put this down at 9. I'll tell you why. This is the primary criteria here, so it calls it comp 1. It's the primary. Now, over here is the delta mag to the secondary. Now, the reason I changed that to 9 is I'd like to keep I don't want the stars to be fainter than 11. Not that you could go to 12, but I'd rather keep it fairly bright if I can. So this would say that the secondary, if the primary were 9, the secondary could be as faint as 11. Okay. This is a speckle sort of range, but I know what the heck. We'll leave it at speckle range, but I don't need to go down to 10. I think I'll go to 8. Okay, so the separation will be anywhere from 2 to 8. And now this is just leave this as any, don't use Gaia double. There is a little bit of Gaia data in here. It's an attempt to match, it was attempted to match the WDS RA and DEC and find the related Gaia star. It's not entirely certain, so it's not something to be necessarily relied on. I believe the GDS 1.03 is more reliable there. But none of it, neither one can be fully relied upon. You need to really go into Aladdin down or Gaia directly and pull that Gaia data out. One point about that, if you go to Aladdin 10 or 11, it now has Gaia DR3, data release 3, which is much more complete than the Gaia data release 2, DR2. And this was built on DR2. So that's a further reason not to rely too much on the Gaia data here. So don't use search, just apply filters. There it is. Okay, well, we came back with 90. Okay. I did it by RA, but let me say I want to do it by separation. I better believe that it's going to, the closest will be around 2, but let's just see. We're going to do ascending. And so I'm going to click at this. And there it is by separation. And there it is. The lowest, closest one is 2. Okay. Now, I can also do it by number of observations. Let's take a look at this cert right here. Here are notes down here, but this is your WDS number that you're going to want to use. Here's RA and DEC that you can use in Aladdin, for example, to get to pull up an image and also the Gaia data. You can go through this and identify ones. In this case, you say, okay, I want something that's, if I were doing speckle, that's in this range, and I can say, okay, here's a separation of two. Let's take a look at that. Magnitudes are probably okay. There's just star class. Here's notes. And this is particularly interesting because the WDS has note codes for some stars, and it's based on papers have been written about that pair, and where the author has made a recommendation or a conclusion that they can provide a little more information about that particular pair. Now, you can find the actual codes here. And so you can see what they are, note codes, and you'll be able to read through them. And there's some that are quite interesting. But the N one I find is not very interesting. I can't quite understand what that means. But if I scroll down, here's an O, and O says orbit has entry in orbit catalog, a 6 orbital catalog. So this is one that they've concluded is orbital. So notice there's a lot of them that have no conclusion, and they're close. Okay, here's one that's got 144 observations. Pretty amazing. And it's whatever that end note means, I don't know. You'll get a more complete definition of the notes when you get your historic data back from USNO. And I definitely would look at that. And if possible, in your paper, I would like in your conclusions for you to address a note, if you can make a recommendation on how it should be classified. Now, let's just look at this by number of observations. Bingo. Number of observations, look at that. Ones. This would be perfect for identifying ones that are neglected, seldom observed. Here you see some that only had one. Now, X on this one is interesting. But look at that. It says a dubious double, bogus binary. Love that. It's probably not. Someone's made a recommendation. Looked at it, says probably not a true double star. Now, based on one observation, I don't know how they made that particular conclusion. So one could definitely look at that and see if you could find that, and see if you could find that particular star, and try to confirm that it is a pair. But that'd be maybe a risky sort of undertaking. We've done that before. But these are certainly neglected. But you can see this went back 1895, 1895, or 1896, 1895, and nobody's seen it since. That we'll get into in class. That's why it's a little bit difficult to know whether that was a valid observation or not, and when you can find it today. At any rate, you can go on down here and say, oh, wow, look at this. It's 271 observations. And it's got the tag N note again, but L, what does L mean? Linear solution. Linear elements for this pair have been determined, and in linear elements. So we didn't talk about that, but that's the rectilinear catalog, and this is one that you would use for calibration because they seem to be moving linearly together, and you can predict where they'll be, what their separation and position angle will be, so that if you can calibrate your telescope to that and your system to that, to confirm that you're getting good measurements. Here's another O, which says orbital. Of course, it's got lots of observations. Keep coming up to these ends. That troubles me. Anyhow, that's how you do it. Oh, one final thing. You can't really download this because I wish you could. GDS 1.03, you can download to a spreadsheet and analyze further, sort it other ways. Aside from that, GDS 103 has more data. So you can identify one and save it to a run list, and identify another and save it to the run list, and it'll save it to a notepad, and that notepad will be a CSV file. And I've not found a good way, for some reason, in that particular CSV structure. I don't know why it doesn't readily translate into a spreadsheet. And so I found it not very useful. So I don't recommend trying to do this. So what you do is I would just use the sort features and the selection features and see if you can identify the ones that interest you, and then, pick up their WDS number. You can pick up their separation, of course, and then pick up their RA and DEC, and from that go into probably Aladdin, or go to Aladdin to get your parallax, because parallax will be critical in your initial sorting. I think that probably covers it. So I hope this helps. And there is a data dictionary to explain what each one of these columns mean. Good luck in your searching.